Hey everyone, welcome back to the channel. Today, we're diving into the world of mechanical motion and meeting two legendary components that silently power everything from race cars to helicopters, the crankshaft and the swash plate. Now, I know what you're thinking. Wait, aren't those just some parts buried inside engines? Well, yes, but they're also the magic behind converting straight-line motion into rotation, or vice versa, the kind of magic that quite literally keeps the world turning. By the end of this video, you'll not only understand how these two components work, but also why they're becoming even more important in our electric, automated, and AI-driven future. Let's rewind the clock, back to the age of steam engines, when engineers first asked a critical question. How do we turn the up and down motion of pistons into the circular motion needed to drive wheels? The answer? The crankshaft. Think of the crankshaft as a conductor of mechanical motion. It takes the chaotic up and down movement of pistons and transforms it into smooth, continuous rotation. At its core, the crankshaft relies on an offset or eccentric axis, coupled with connecting rods, to achieve this conversion. You'll find crankshafts in almost every internal combustion engine, from your car's engine to high-performance beasts like a Ferrari V12. When that engine roars to life, the crankshaft is spinning at thousands of RPM, orchestrating the entire system. And here's a cool fact. An engine's displacement, essentially its size and power potential, depends on the stroke length and bore diameter of its pistons, all controlled by, you guessed it, the crankshaft. Now, let's talk about the swash plate, a mechanical genius with a flair for precision. Unlike the crankshaft's brute strength and durability, the swash plate shines in applications where fine control over motion is needed, like hydraulic pumps, aviation systems, and certain axial piston engines. Here's how it works. Imagine a tilted disc mounted on a rotating shaft. As the shaft spins, pistons arranged around it are pushed back and forth depending on the tilt angle. By adjusting that tilt, or swash angle, we can precisely control the stroke length of each piston. This gives engineers dynamic control over fluid displacement, pressure, and even rotor blade angles, all in real time. Take the Apache attack helicopter, for example. Its swash plate system allows pilots to change rotor blade pitch mid-flight, enabling maneuvers like vertical takeoff, hovering, and rapid directional changes. Without the swash plate, the helicopter would be little more than a spinning fan. Historically, the roles of these two components have been clear-cut. The crankshaft rules the internal combustion world, cars, motorcycles, trucks, where high-speed, high-torque rotation is needed. The swash plate dominates the hydraulic and aerospace sectors. Think construction equipment like excavators and loaders, where swash plate-type hydraulic pumps are used to power lifting arms, drills, and blades. These hydraulic pumps were typically directly driven by diesel engines via the crankshaft. The pump's output was adjusted by tweaking the swash plate angle through a hydraulic pilot circuit or electromagnetic control valve. But here's the limitation. With a fixed engine speed, the only way to control flow was by changing the swash plate angle. That's not ideal for energy efficiency or precision. Now comes the game changer, electrification. As vehicles and heavy machinery move from diesel to electric or hybrid drives, swash plate pumps are now being coupled directly with electric motors. This unlocks two key advantages. 1. Variable motor speed. Thanks to inverters and motor controllers, we can precisely tune the motor's RPM. 2. Dual control. Both motor speed and swash plate angle can be adjusted simultaneously. Let's make this real with an example. Imagine a hybrid excavator. When the operator needs fine digging control, the system reduces motor speed and slightly adjusts the swash plate for low-flow, high-precision operation. But when heavy lifting is required, both the motor speed and swash plate angle ramp up, delivering high flow and pressure. This smart control results in optimal energy use, whether you're handling delicate tasks or brute force jobs. Thanks to modern digital controllers and real-time feedback sensors, we now have intelligent hydraulic systems capable of high-resolution angle control, even down to 0.1 degrees adjustments, instant pressure and flow compensation, predictive maintenance, detecting anomalies by monitoring swash plate response times and behavior. Even better, we're seeing the integration of AI algorithms that process sensor data and automatically adjust swash plate angle and motor speed based on load conditions, maximizing efficiency and minimizing energy waste. This is called multi-strategy control, or simply smart hydraulics. There's even talk of applying MPPT-like logic, maximum power point tracking, common in solar energy systems, to hydraulic pumps so they can dynamically seek their best efficiency point, BEP, in real time. Back to helicopters for a moment, because no discussion about swash plates is complete without them. In helicopters, every motion, lift, pitch, yaw, is controlled by adjusting the rotor blade angles. And how is that achieved? Through the swash plate assembly. Here's the breakdown. Collective control changes all blades' angles simultaneously, affecting lift. Cyclic control adjusts each blade's angle throughout its rotation, creating directional thrust. Without the swash plate, helicopters would be uncontrollable. With it, pilots can perform delicate maneuvers with precision, and yes, even hover in place like magic. As we look to the future of smart machines and autonomous systems, both crankshafts and swash plates are evolving. We're talking electrohydraulic swash plate control, adaptive load sensing systems that optimize performance on the fly, energy recovery through regenerative systems, using hydraulic accumulators and electric motors to store and reuse energy. Add in edge computing and AI prediction models, and soon these systems will self-optimize based on mission data and environmental inputs. Crankshafts and swash plates are transforming from simple mechanical parts into intelligent modules, merging power, control, and data into one package. From the steam-powered machines of the 18th century to the electric, AI-driven equipment of tomorrow, crankshafts and swash plates have powered our world, and they're not done yet. As we shift towards smarter, more efficient systems, these classic components are being reimagined. Not just as tools of motion, but as core enablers of intelligent power control. Thanks for tuning in today. Until next time, keep building, keep innovating.